Hey guys, so today we're going to continue the topic of trigonometry, and this is trigonometry part 3. If you didn't watch part 1 and part 2, I highly recommend that you watch those before you watch this one, because a lot of the concepts discussed in those videos going to be in this video. Okay, and in this video we're going to deal with the addition theorem and the double angle formulae. Okay, so let's jump right into this. So we have sine A plus or minus B, right? And we need to learn the expansion for this, okay? So the expansion for sine A plus or minus B is the same as sine A cosine B plus or minus. So what that means is that the plus here goes with a plus here, and when here is minus. Plus or minus cosine A sine B, okay? And that is the expansion for sine, okay? Now we need to learn the expansion for cosine now. The expansion for cosine A plus or minus B is cosine A cosine B minus plus. Notice that the plus here goes with the minus sign here. Okay, this is a common mistake people make. They forget about this part. Okay, minus plus sine A sine B. Okay, so cosine A plus B is cosine A cosine B minus sine A sine B, while cosine A minus B is cosine A cosine B plus sine A sine B. Okay, and then we need to learn the expansion for tangent theta. Okay, so the expansion for tangent theta is tan A plus or minus tan B all over 1 minus plus tan A tan B. Okay, so tan A plus B would be tan A plus tan B over 1 minus tan A tan B, while tan A minus B would be tan A minus tan B over 1 plus tan A tan B. Okay, so these are important formulas which you need to know. Okay, so the next thing we're going to do now is the double angle formula. So those three on top of the addition theorem. Now we need to learn the double angle formulas. So how do you get the double angle formulas? It's pretty simple. You don't even have to memorize it. Okay, this is the same as writing sine theta plus theta, because theta plus theta is 2 theta. Okay, so again, if I in the first one, if I have sine theta plus theta, it would be the same as sine theta cosine theta, okay, plus cosine theta sine theta, and this is equivalent to 2 sine theta cosine theta. Okay, so sine 2 theta is equal to 2 sine theta cosine theta. Okay, then we have cosine 2 theta. Again, this is the same as writing cosine of theta plus theta, okay, which is equal to cosine theta cosine theta sine theta minus sine theta, sorry, it's cosine theta minus sine theta multiplied by sine theta, which is equal to cosine square theta minus sine square theta. Okay, so the equivalent of cosine 2 theta is cosine square theta minus sine square theta. Now, there are actually 3 iterations for cosine 2 theta. How do we get these iterations? You don't have to memorize them. Just remember how you get them, and then it's easy to derive. So we know that is equal to cosine squared theta minus sine squared theta. Remember Pythagoras theorem, which says cosine squared theta, sorry, not Pythagoras, but derived from Pythagoras, plus sine squared theta is equal to 1. So what we're going to do is we're going to replace cosine squared by 1 minus sine squared theta. Okay, and this would be the equivalent of 1 minus 2 sine squared theta. Now, if we make sine squared theta the subject of the formula here now, and substitute that into the equation, we'll also get sorry, 2 cosine squared theta minus 1. Now these three are all important and you need to know all three, okay, because they tend to come up a lot and depending on the situation you need to know which one to use. Okay, now tan 2 theta is the equivalent of tan into theta plus theta, okay, which is equal to tan theta plus tan theta all over 1 minus tan theta, which is equal to 2 tan theta all over 1 minus tan squared theta. Okay, and these are important, you need to know this. So tan 2 theta is 2 tan theta over 1 minus tan squared theta. Cosine 2 theta has three different iterations. It's cosine squared theta minus sine squared theta, 1 minus 2 sine squared theta, and 2 cosine squared theta minus 1. Okay, and then sine 2 theta is equal to sine 2 sine theta cosine theta. Okay, and with that, let's try some questions to understand what we just learned. Okay, so given that A and B are acute angles, now this is important here that they are acute angles. You will understand why in the next video actually, why it must be acute angles, because if they are not acute angles, you would actually get different results and so on, right? And it take a little more effort in finding the answer. Okay, given that A and B are acute angles and sine A is equal to 4 over 5 and cosine B is equal to 12 over 13, calculate. And normally questions like these, they normally say calculate without using a calculator. Okay, we're going to find cosine A plus B. Okay, so you know some people will say, okay, find angle A by finding the sine inverse of 4 over 5, but that's not what you want to do because they said do not use a calculator. Okay, so what we're going to do now here is actually we're going to expand this out. So this is the same as writing cosine A cosine B minus sine A sine B. Okay, so now we expanded it out. Okay, now we want to find the values. We know sine A and we know cosine B, but we don't know cosine A and sine B. So first let's deal with A. Okay, we have a triangle here. Okay, this is angle A. Now we know sine theta is opposite over hypotenuse, so in this case this is the opposite, this is the hypotenuse, so it's opposite over hypotenuse. Okay, now we want to find, using Pythagoras theorem, this missing side. So therefore, this missing side would therefore actually be 3 once you calculate it, because it will be the square root of 25 minus 16, which is equal to the square root of 9, which is equal to 3. Okay. Now, we want to deal with B. Okay. Angle B, cosine theta now is adjacent. So this here, adjacent over hypotenuse, so the adjacent here would be 12. And the hypotenuse would be 13. Again, we use Pythagoras' theorem, which is ideal for right angle triangles. And we would get here, so it would become 13 squared minus 12 squared, 169 minus 144, which would be for equal to 5. You get here as being 5, okay? So, now we can actually simplify and calculate this. Cosine A, what is cosine A? Cosine A, we have A, cosine A is adjacent over hypotenuse, so it would be 3 over 5. Cosine B, which is 12 over 13, minus sine A, which is 4 over 5, for sine B. Sine B now is opposite over hypotenuse, which would be 5 over 13. Okay? And this here now, I would use my calculator. Again, I highly recommend you get a Casio calculator because they tend to be the best when solving questions like this, because you're allowed to use the fractions part of it, which comes in really helpful. Okay, and this is equivalent to 16 over 65. Okay, now we want to find sine A minus B. So first we want to expand this out. This is the same as sine A cosine B minus cosine A sine B. And we can calculate this because we already found this. So sine A is 4 over 5, cosine B 12 over 13, minus cosine A. Cosine A is adjacent over hypotenuse, which would be 3 over 5. And then sine B, which would be 5 over 13. Okay, and then let me just get my calculator to calculate this. So it'd be 4 over 5, 12 over 13. When you're doing these, watching these videos, by the way, what you could actually try to do is do the questions, pause the video and do the questions, and then see if you get the same answer that I get. Okay, and that way you'll actually get practice yourself. And this works out to be 33 over 65. Okay, now, and that's it for that question. Okay, so again, remember what sine represents what cosine represents, and you can always draw a triangle. Okay, now the next thing now is calculate cosine of 7 pi over 12. This is a common question, and I normally tell you to not use a calculator. Okay, and for this one, what we need to recall is the common angles. So what are the common angles? 30 degrees, 30 degrees, 45 degrees, and 60 degrees. Okay, pi over 3, pi over 4, and pi over 6. Okay, now for a question like this, 7 pi over 12. Okay, let's stick to working in radians. So 7 pi over 12. Okay, if you want to find 7 pi over 12, okay, this is the same. If you want to put it in degrees, okay, this would be the same as, okay, let's see, multiply by 180 over pi 7 times 180. So this is the same as actually 105 degrees. Okay, now notice that 105 degrees is also equal to 60 degrees plus 45 degrees, which are common angles because we know to find the sine, cosine, and tangent of these angles very easy. If the angle is not 0, 30, 45, 60, or 90, you normally have to use a calculator to find the angle, right? So if they tell you to not use a calculator, you want to express this in terms of common angles, okay? So this would be the same as pi over 3 plus pi over 4. So rather than write it as cosine 7 pi over 12, we know the formula, so we can actually write this as cosine pi over 3 plus pi over 4. Okay, this here now is, if we expand this, is cosine pi over 3 cosine pi over 4 minus sine pi over 3 sine pi over 4. Okay, and now you're supposed to know what these angles are, okay, in the exact form. So cosine pi over 3 is a half, cosine pi over 4 is root 2 on 2, or 1 over root 2, minus sine pi on 3 is a half, sine pi over 3 is a root 3 on 2, and sine pi over 4 is 1 over root 2. So this is the same as 1 over 2 root 2 minus root 3 over 2 root 2, which is the same as 1 minus root 3 over 2 root 2. Okay, and that's the answer. That's normally how they want you to work it out, right? Now another common one would actually be pi over 12. How do we get pi over 12? Pi over 12 is equal to pi over 3 minus pi over 4. Okay, so someone they can ask to find cosine or sine of pi over 12, and in this case you have to break it up into pi over 3 and pi over 4. Okay, so again, try to break up whenever I tell you without using a calculator. Look at pi over 3, pi over 4, and pi over 6. Okay, we have a next identity here now. Prove that sine theta plus cosine theta all squared is equal to 1 plus sine 2 theta. So again, the left hand side information has more data, so we can start off with that. And remember, the only thing you can really do is expand. Okay, so what we'll have is sine theta plus cosine theta multiplied by sine theta plus cosine theta. Okay, expanding this now, we get sine squared theta plus 2 sine theta cosine theta plus cosine squared theta. Okay, now remember we have sine squared theta plus cosine squared theta, so this is equivalent of 1 plus 2 sine theta cosine theta. Now notice we have the 1, so it's clearly obvious that this here, if you remember the double angle formula, this is the same as sine 2 theta. So it'll be 1 plus sine 2 theta. And that's the proof for this question. Okay, and that was the end for this video, which covers the addition theorem and the double angle formula. I hope you learned something, and remember to please memorize these equations. And I hope you learned something in this video, and look forward to the next one. Thanks for watching.